Hello, hi everybody. So we will see today that what do you mean by strains. So a lot we have seen about the stresses, and now we are left with a very important topic that is on the strains. Okay, so we will see it out that what actually is strain all about. So I've told you that thing that in which the stress or strain, which will come first, the stress or strain, which would come first. Okay, so like if I say stress and say strain, which would come first? Which would come first? So what actually happens is that unless and until there is the change in shape, mark my words, it's unless and until there is change in shape, or we can say dimensions, right? No opposing force, no opposing force will come into play, will come into play to get that initial dimension. It means what? Suppose if we have applied a force on a rod of the length L, say like this one, P, right? There will be some change in the dimensions, right? So some internal forces will be set up inside the body. Those internal forces acting per unit area, that will be known as the stresses. So it means what? That unless and until there is a strain, there will be no stresses, right? So we can say like that, that unless and until there is no strain, there will not be any stresses, right? And why is this stress having, why they come into shape? Because to make the body revert back to its original configuration. Yes, right? Okay, fine. Okay. So now we will see that what are the different types of strains. What are the different types of strains? I should write like different types of strains, right? So strains are there: linear, right? Lateral strain, volumetric strain. Okay. Okay. Linear strain is also called as longitudinal strain. It means what? That when there is some change, there is some change in the linear direction, in the linear direction, like there is there is change in shape, not in shape, sorry, length, linear dimensions, like breadth, height, right? So all these changes which we used to see in the body, they will be known as the linear or longitudinal strains. Okay. Now we come to lateral strain. Lateral strain, we can take it in two ways. Okay, we can take this in two ways. Okay, if we say about the lateral strain, it will be explained in two ways. The first one is there, the change in the lateral direction. Second thing is there, change in area. Okay, most of the matlab, most of the books, if you see, they have explained the lateral strain in the terms of the change in the lateral direction. It means what, that suppose there is the rod of length L, and if you apply a force out here, say P, then is that is also there 5, right? There will be the change in length L. L will get increase, means, or we can say that L will elongate, but dia will decrease, right? L will increase, but the dia will decrease. Okay? This decrease in the dia, if we see, it is acting in the lateral direction. Means decrease in dia is acting in the lateral direction. Means 90-degree, or we can say perpendicular to the longitudinal direction, right? Longitudinal direction. So that is what known as the your lateral strain, right? So in that case, we can also see that suppose this is L and this is D. So this is the change will be your delta L here, and the change will be the dia, that will be your delta D, right? So we can also explain that is there any change in the area of the cross section also? We can say that area of the cross section we can say out here. Suppose the length original dia rod would be your D, right? So it was its area pi by 4 D square, right? And now the D has got decreased, right? So it is D1. So now the area that has come into the light is pi by 4 D1 square. So the change in area that we have seen is pi by 4 D square minus pi by 4 D1 square. That's it, right? So pi by 4 D square minus 1 square. So it is all about your what? The change in area, and if you take the ratio of its change in area upon the original area, that is your known as lateral strain. Right? Now we will see that what is volumetric strain. Obviously, from the name we can infer it out that the volumetric strain is change in volume. That's it? No, it's not like that. The change in volume upon original volume. Original volume. Now this change in volume, it could be your negative as well as positive also. Means the volume has been decreased, right? And in this case, the volume has been increased, right? So this is all about your change in volume, okay? And this is your original volume. So it's all about your strains. Okay? Now in the next lecture, we will see that what is the relation between stress and strain. Okay, and what are the different elastic moduli? What is Hooke's law? Okay, we will see all this in the next lecture. Till then, bye bye. Take care.